Hey guys, it is Captain Wolf, and this video will be about how you can write your own token impersonator, and you can use that in your own penetration testing assignments. Metasploit or some other C2 frameworks have their own embedded token impersonators, but since these are popularly used, you might get flagged down when you might be using them if you are a beginner like me who just drops binaries on the systems and then uses it without much obfuscation. One way you can avoid being caught by the antivirus systems or any sort of IDS on the workstations where you are pen testing is by using your own programs, your own tools, your own written tools to do that. And this video is going to be about how you can make your own token impersonator. If you had watched my previous video, the link will somewhere be in the description or probably on the screen somewhere. But if you had watched my previous video, you will know what tokens are, how Windows uses them, what different types of tokens are. So I'm not going to go over them in this video. You can watch the previous video if you like. Instead, I'll walk you line by line through the code. It's a small okay, let's introduce you to my repo here. Every code that I'll show in this video will be available in my repo here. It's www.github.com/ my username Captain Wolf, Captain-Wolf, and then PowerWolf. I'm talking about the PowerWolf repository. So just go there if you wish to see any code or use any of the classes, because you would need them. I will be using a couple of classes while making this token impersonator, and the classes I'll be using are, okay, let me demonstrate. A couple of classes. See, I needed to make an impersonator that could list out the processes and their tokens inside them, and for that I needed something that C++ didn't have by default. Structures like dictionary, a dictionary of lists, or maybe even linked lists and stuff like that. So instead of putting everything in the same code here and making it gibberish, I decided to write different classes for it. So you can simply use these classes for any of your projects, or even for this one. Everything is properly arranged and well documented, so I don't think you would have any problem using them. So let's jump into the main code. If you had watched my previous video, you will know that tokens can be used to impersonate a user on the system, and the level of impersonation tells you what and how much can you impersonate them. So before starting, let us put down the steps that we need to do in order to impersonate a client on the system. Let's go. So these are my notes from the previous video. So let's make a mental map of what we are supposed to do. First things first, we need to enumerate all processes running on the system. We need to enumerate every single process and see who is the owner. Let's say we want to impersonate anti-authority system. So we need to enumerate all the processes and see which one of them are running by the anti-authority system. Even before this, however, if you want to enumerate every single process and then later impersonate them, you must have a privilege called SC impersonate, or was it impersonation? I think impersonate privilege. Yeah, this privilege allows you to impersonate a user from their token. So I'll write that. Okay, so check if this privilege is there. Then we'll see who is the owner of all the processes. Then after the user tells which user he is looking to impersonate, then what we need to do is, okay, let me write the names of the functions here. First thing is we need to open the process. It's a process. I will show on the MSDN page what open process is and what the signature looks like. So we open a process and get the handle to the process. We use that handle to open the token of that process. Then was there any other step? No, I think then we had to duplicate it. No, was it duplicating? Duplicate token X. Yeah, this is the process. This duplicate token X process will help you to duplicate any token that you got from this previous step here. After duplicating the token, you can simply then create what was the name? Windows has these weird and big process names, but also descriptive. Create process with token. Let's use the Unicode version. W, and then you can impersonate a client. So these are the four main functions that you have to use in order to impersonate a user, although there are many more functions that I have used throughout this code, and I'll show you which ones am I talking about. But this is a mental map of what we are supposed to do. First, check for the privilege. If the user is allowed to impersonate someone, then you need to enumerate all the processes and extract the name of the owner from those processes. Then let the user choose which owner he wishes to impersonate. Then follow these steps. Open the process and get its handle. Use that handle to get the token of the process. Use that token to duplicate and produce a new primary token. Use that primary token to create a new process. This is our mental map. I won't be typing the code, but instead I will read the code line by line and see what show you what each line does. So ignore this here, it's just a small handler routine. I'll come back to it later when I show you what I did with the piping. These are the structures that I wrote for the sake of this code to make stuff easier. Whenever you're enumerating processes, I'm storing it under structures called process info. It contains the PID, SID, name of the domain of the users, and the name of the process that we currently enumerated. I'll show you what it means. Let's jump to the main code here. All of these can come later. I'll show you what everything else does. Okay, so first things first, we're checking for some arguments. We are parsing the arguments, basic stuff. This here is an important step, the first step in our mind map. SE impersonation privilege. We need to check if this privilege exists. So I have written a class for that. It's called the privilege manager, I suppose. Yeah, token privilege manager. You can use this class. All this class. I wrote this short paragraph here, so you can see that what you need to use this class. You simply need to initialize this with passing the token to the constructor. So here you can. Where is it? Why can't I see my own? Yeah, we have this function called check for required privileges. Alright, I put it in a different function, it seems. So, come on, where is this? Check for required privileges. So let's see what this does. Whenever we set the check for required privileges, if you remember from our last video, any process that has been started by you after you logged in got a copy of the same access token that you got while you logged in. So in order to know what privileges you have, it is sufficient to extract the token from the current process that is running, because remember that this process is a child process of the parent process that launched it. So in order to get what access token you have, it is enough to extract the token from any processes that you have launched, because they will contain the same token, no? So what this does is that it uses open process. It is one of the many, countless perhaps, Win32 API functions. And you can read more about them on the MSDN site. I won't go much over them because these are different topics. I suggest that if you do not know how to use Win API functions, there's a guy, Russian guy, I suppose, Yusel or Yusuf Pavelovich on YouTube. Yeah, and he has a wonderful set of videos on Windows API functions and Windows internals. So just go through them. If you know, however, let's continue. So you use open process with this privilege. This process query information. This allows you to open the process with the query permission. So you can query anything that the process has, and in this case we will query its token. You use that, get the current process handle. You use the current process handle, as I said, to get the open process token. You use that token with my class. You see that my class that I just showed you here, this token privilege manager. You initialize that class, an object of that class, with the current process's tokens. And after you do that, the class is very handy. You don't have to do anything on your own. All you need to do is to use the built-in functions of that class. So I'm simply using this function is privilege present. As impersonate privilege, as I said, is required if you even want to impersonate someone. So this class checks for that privilege, and if this privilege is here, it enables that privilege and then returns true. Wrong indentation. I might have to fix that later. Doesn't matter. Anyway, let's continue. After we check for the privilege, the immediate next step is to enumerate all the processes. Now this is a gigantic code, and if you are not looking to allow the user or yourself the freedom of choosing which user they wish to impersonate, and if you just want by default, if you want to hard code a name of a user and the domain while you are writing the code, you do not need to enumerate all the processes. The only reason I enumerated all of these processes is to just find out which processes are run by which of the domain users and then list them out. So this portion of the code here simply lists the users and what programs they're running on the system, and then it provides a choice to the user who wishes to impersonate them. So ignore this, ignore all of these if you wish to do. These structures here, list structures, are taken from my class folder here. This list is probably a linked list, so you can have it from here, linked list. You can use these classes to help you in your programming if you need it. Then this simply shows the users who does what and stuff like that. If you wish to, however, let me just go over this code a bit better, I suppose. This is a dictionary, no? Running processes. No, it's a linked list. It's a linked list. Weird though. Running processes should not be all. Okay, whatever. I might have done something. Moving on. Yeah, I was right. Running processes is not a linked list. Running processes is a dictionary also available in my classes here. So it's a dictionary, and I'm simply using that to see which user is running who. And like dictionaries in Python, you have the name of the users as the key, and you have the list of processes as the data. It's the value of that key. Nothing important. Let's not bore you guys. I think I'm boring you guys with these, but it's important to know because whenever you're using C++, there are lots of things that are not built in, and you have to write the boilerplate code yourself. Too much, but it needs to be done. So where was I? Let me alright, after that, after we enumerate, and how are we enumerating? Let me show you that function. Running processes, running process size. Yeah, so this is the function here, enumerate running processes, and what this function does. Let me. Yeah, so what this function does, very simple. It takes a snapshot of all the processes running on the system here, and then uses that snapshot to enumerate over all the running processes in that current snapshot. Here you can use these macros available. MSDN has a better information about what this is, but there are two macros here, process 32 first and process 32 next, and you can use these macros in order to get the in order to simply iterate over all of the processes inside the current snapshot. Go over all of these processes and extract the information from them. These are some helper functions that I have here running. Get process info is a helper function I wrote to take the process entry 32 structure, and then use that to extract the information about that process. Stuff like the PID, stuff like who is the owner of the processes, who is the domain of the user, if any at all, and stuff like that. Get process info. Let me also demonstrate what this get process info function is. So it takes a process entry 32 entry and creates the SID and stuff like that, and it gets the token information. This is a truckload of code, I agree, but that's just the way it has to be. It gets the name of the process that is running, it gets the owner from functions like these that first locate the SID of the owner, and then followed by that resolving that SID into the name of the owner and the domain, which is also here somewhere. Let me zoom in the code. What am I doing, guys? Yeah, I think this one. Yeah. Get token information. It gets the SID, I suppose. Token owner gets the SID. No, get token. Let's see what we are. Process token owner. Yeah, process token owner. We are using the token owner here. We're using the token owner, which is an enumerated class of a member of the enum class. This token owner. And let's not go over the code too much. I'm boring you guys. Yeah, then you get the SID. You use the SID to look up and to see that who owns that SID and which and what is the domain of that. This is how you're supposed to use functions like lookup account SID. You need to use them twice, because the first time you use it, it will fail because you won't know the size of the buffer that you must use with the function. So the first call actually sets the size of the buffer. It tells you what the size of the buffer must be in order for this function to succeed. If these kinds of functions fail, this is what the function returns. It returns to you the size of the buffer. So once you set these sizes in the buffer, you call the function again, but this time with the correct size of the buffer, since you already know them from the last time you called them, and stuff like that. Let's zoom out. You can read this code if you wish here in my repo. You'll find everything available here. Let's go to the main stuff, the main juicy stuff. After having enumerated everything, every process you have, you ask the user for their choice, then you start the impersonation. And this is where things get a little interesting. Ignore this portion of code here. I'll come back to what this 4 lines says. Ignore this piping section. I'll come back to this at the end. So you start impersonating, ignore all of these huge code, but what this is doing in gist is that remember this dictionary structure that we were filling up here, somewhere around here, yeah, here, along with the keys as the domain names, usernames, and the values as the processes. Well, we use that dictionary here, we iterate over all of them, or all of the processes, and see that which one of the users match with the user that the current user wants to impersonate. And when they match, we call on another function I wrote here, impersonate, and spawn the process. And this is where the magic happens. Let me take you to that process. And this is the main gist, the main thing that happens. Ignore all of these. I'll come back to this. So now let's come to the juicy part, the part that I've been waiting for. These 4 processes called in succession, one after the other, in order to impersonate. First, we open the process, and we open the process that the user has chosen as the target. The target PID is an argument to this, no? Yeah, it's an argument to this main function. So we open the chosen. So for example, let's say that the user wants to open the conhost process, conhost.exe, and the PID of that, let's say it's 3000. So 3000 is the value here. You open the process with process query information, and then you use that handle, pass it to open process token. With this is important. If you wish to impersonate a token, you must have this token in duplicate. This is where I think it differs with thread tokens. If you wish to impersonate a primary token, you use token duplicate. But if you wish to impersonate if you wish to impersonate with an impersonation token, you must have token. Let me see what it is. Now, I was wrong. I checked the documentation. Now, duplicate token X, this function which helps you to duplicate the token, does not require you any other access to the token except for token duplicates. So yeah. No, even if it's a primary token or a thread token, it doesn't matter whichever it is. You simply need to open that with the token duplicate access for both of them. Same for both of them. So you open the token with the token duplicate access. Then you duplicate the token. Any function that you see here that is offered by Windows API will have its documentation on the MSDN site, so you can simply Google for that, no big deal. Then you duplicate the token and have token all access. It's better that way. And this is, if you remember from my last discussion, you had 4 different levels of impersonation. No, I'm using the 3rd level of impersonation, the security impersonation, and not the delegate one. So we duplicate the token, and then we use that token to spawn a new process. The last function here, create process with token W. Create process with W. Let me see. Alright, before that I'm using another of my classes, the token privilege manager, and you need to, I showed you this above, no? Yeah, I did it. You use this with the token that you just created, you just duplicate it from here. Use this to enable all the privileges in that new token. So after impersonation you have all of the privileges that are allowed enabled. Let's come back to the piping later and then create process with token W. You use this along with all of the parameters it requires. Read about more about it in the MSDN documentation, but basically what you need to do is pass it the new token that you just duplicated here from the target process. Log on with profile simply states that you were creating the new process with having loaded the profile of the user. So stuff like environment variables and all of that will be available. I don't know much about stuff, so you better read the documentation. Seriously, Windows is a jungle. Anyways, then you need to have the process to launch. It's an argument. The user can choose to launch whatever he or she wishes. Then the process creation flags. Now let's go for these. What did I put? Yeah, here. So now let's introduce it to what this window needed stuff is. So it's an argument. You pass it to this code, and if the user chooses to have window needed, that is launch the process inside a new window, he or she can do that just by passing the argument. And internally what happens is that process creation flags are a couple of flags that tell this create process with token W function about how to create the process. So if the flags are create new console, a mix of create new console and create new process group, what happens is that the new process that is spawned is separated from your current process, in the sense that your process won't be the parent of the new process that was spawned, and create new console simply creates a new console for that application if you wish. And if you do not need the window, I'm setting this same process creation flag to create no window, and what this does is that it allows the process to run, but it does not create a window, which is a sneaky way to run any application if you wish. I mean, as penetration testers, this comes very handy if you do wish to create a window without having the user to see what is being created. If you are stealing their session, live session, whatever, this is very handy in that case. So you create the process with the token along with whatever process creation flags you have. These two parameters are probably, don't remember, but these are default, so it is a null. You can read more about this in the documentation. And this startup info, and this is a bit important now. Let's come to the piping now. I was reading more about pipes just yesterday, and I figured this out, how to do this. It was damn, I found no documentations written by anyone who allowed what I was thinking about doing. See, what I wanted to do is, what if you opened a process with no window but you still wanted to be interactive with it? Like if you have used consoles before, if you are a CTF player, or even in your penetration testing assignments, you must have used the consoles library, right, to write your sample little Python codes to maybe crack a program whatsoever. So in that module there's a very interesting function that allows you to simply be interactive with any process that you spawned, and it's very useful. I wanted to do something with this here, because if the process you open has no window, then how are you supposed to interact with it? So I wanted the standard output and input of that process to be merged with the stdout and stdin of the current process, so you can interact with that process while inside this process. So even if you do not have a window, if you just have a shell, you can use that shell to interact with the newly spawned console program. So I wanted the piping to be done, and this is how you can do it. Startup info here is a structure also inside defined inside windows.h header file. I think I'm making this too complicated. Ignore this. So startup info, you need to set the handles to the stdout, stderr, and stdin of the new process to be the ends of the pipes. And this is where I must show you the pipes. Why did I? Okay, these are global variables. No, Yeah, I remember these correctly. You need to create pipes that help you communicate with the new process you spawn. If you do not know about pipes, Windows have two different kinds of pipes: anonymous pipes and named pipes. Let's not go over named pipes for now. Anonymous pipes simply help to share data between two or more running processes. No, anonymous pipes, I think, between two processes, yeah. And named pipes between two or more processes. So you create some handles, four of these, make them global so they can be accessed anywhere. And inside my main function, the code that I skipped in the first part of my video, now let's come back to it. Where is the pipe? Where are you? Create pipe. Here, if piping is needed, if the user chooses to use piping, the create pipe function is used to create two pipes, one after the other, one for the std out and other for the std in. And simply what a pipe is that one end of the pipe is used by the current process, the other end of the pipe is used by the target process, and whenever you are using this for std out, the target process writes to the right end of the pipe, and the current process keeps reading from the read end of the pipe in order to capture the std out of the target process. The opposite is done in order to provide the std in to the target process. So it takes the input from us, the current process, and then it gives it, or simply stores it, inside the pipe to be later read by the target process as its std in. So in short, we are simply making the process interactive by allowing the current process to read and write from the newly created process. Let's go over the code. Where was I? This is such a big code. Alright, so yeah. Where is this? Yeah. So there was starting info. After you create the pipes, you need to set the correct ends of the pipes to the correct handles, which you do here. One of the things that is not available, MSDN also has an example for piping. It's a very basic one, but this does not show you how to be interactive with the process, unlike what I'm trying to do here. But that example, that doesn't tell you the use of this flag right here, and if you attempt to do this without this flag, it will simply fail. So what this flag does is simply it uses the it allows the use of the handles here. Let's keep it simple, let's not dive right to it. So you create the process, then you close the opened handles, but not the pipes. Remember, do not close the pipes, the interaction will fail if you wish to do. Then it returns. Okay, so after it returns, let's see. After returning, there's last process here. After returning, then there's something additional that we have to do. So we were inside this process all till now. Then we simply print out that the process was spawned correctly and stuff like that. Now if piping was needed, now comes the next portion of the code, which is it creates two threads. These two threads probably have been running before, no? Where are the threads when you need them? Here. You're creating two threads here that can that run simultaneously. One thread handles the std out from the target from the new process, and the other thread handles std in from the new process. So you create the threads, and in here you wait for the threads to finish if the user indeed opted for piping needed. So you wait for threads to finish, then you simply delete the threads, because I used new to create space for the threads. After you delete the threads, you simply close the handles here and then exit the program. Simple. And let me go over the where is it? Let me go over the thread functions too. That is the last thing I need to. This topic is rather boring, no? I mean, but this is how Windows does, so you need to understand the basics if you do wish to write more about or make stuff like these. So this thread function, simply what it does, let me explain to you how the std out handler function captures the standard output from the newly process. So what it does is that it reads from the std out of the new process. Remember that this end of the pipe was inherited by the process, so it reads from that end Whatever this reads, it stores inside the buffer of 2408 characters. You can change this to whatever you need. It stores this inside the buffer variable, a buffer. Then in the next line, it writes it to the current std out. So in essence, what we are doing is that we are capturing the std out from the process, because the new process's std out, remember, was set to be this end of the handle. Then we are using the contents from that handle, storing it to buff, and then in the next line we're reading from the buff and writing it to the current process's std out, which is handled in this line. The current process's std out, we can get that by using the getStanderHandle function, and you keep doing this over and over until it is not running anymore. And isRunning function is running as a boolean variable, which I will show you. And stdin is handled in the exact same way as std out, but in the opposite manner, because you first need to read from your stdin and then write it to the target new process's stdin. I also wanted it to be interactive, so if you press Ctrl C and provide the interrupt signal, I wanted that the process should be stopped, because you do not have interaction with the process if it doesn't have a window. So I wanted Ctrl C to end the new process as well, besides the currently running process. And so I'm using a handler here. Yeah, this handler code, what it does is that it simply captures the Ctrl C event and sets isRunning, which is a global variable, to false. And the moment this becomes false, the thread functions no longer will run, because if you remember, this will run as long as isRunning is true. The moment it is false, it simply ends. Same with the stdin, and after that the impersonation is done. So all of these is just talk. Let's show you this in action. Hey guys, so I couldn't figure out how to run the token impersonator on a VM. I don't know why, but when I tried on Windows 7 VMs, I couldn't find any tokens except for the administrator users. So no tokens for the NT system or something like that. So I hopped on my main machine to show you how this works. This is a Windows 8 machine, so let's see. I run the token impersonator. This is 64, so I run that. I see the usage here, and let's try to run cmd. Okay, before I do that, do know that I am not running as the NT system admin, and although I cannot show you my username, know that I am not running as the NT system authority. You can see that under this blurred text, you can see that this is not NT authority system. Just trust me on that, okay? I can't show my real username. It's quite funny. Can't do that, sorry. Alright, let's try. Now let's impersonate something. Let's try. I want a window. Alright, know what I want? Yeah, I want window, but I also want piping to show or demonstrate how this works. So I create this. Nice. Now I have the tokens of all these. I have NT authority system, NT authority network service, I have local service, my username, my admin user, and then built-in administrators group. So I'll try with the NT authority system. Let's try that, and then after I press enter, this will enumerate all the processes that are running under NT authority system, and then this will provide me with the token. This will be impersonated, and then a new process, that is cmd.exe, will be started with this token, and the input and output from that process will be piped to here. So in essence, you will see a shell pop up shortly. And there you go, we have the C Windows System 32. If I run a who am I, we are running as NT authority system. Nice. Well, and also let us check the privileges, because all of these were enabled, remember? And bingo, we have all of our privileges enabled. Nice. So this is how token impersonation works. I hope this video wasn't too long or too thorough and boring, but some things had to be addressed, and Windows is just that. Complicated yet powerful. So I hope you like this video. See you in the next one.